Hello everyone, this is part 2 of the MAT 1033 final exam review. We're going to start with number 21 where we asked to find the slope of this line. When you're given an equation for a line, you want to find the slope by rewriting the equation in slope-intercept form. Once you put the equation in slope-intercept form, then it's just a matter of remembering what each of these variables, the m and the b, stand for. So after you put your equation in slope-intercept form, remember that variable x and the constant that's in front of the variable x, m, is going to be your slope. So we want to take this equation and solve for y. First, what we want to do is subtract our 5x from both sides of the equation. Now when we subtract 5x, they cancel on the left side and we're left with 3y equals. On the right side, we subtract 5x and we get negative 5x plus 30. The last step we want to take is we want to divide everything on both sides of the equation by 3. The 3's will cancel on the left side, leaving y equals. And remember that negative 5x, we divide negative 5 by 3. That gives us negative 5/3 x, plus 30 divided by 3 gives us 10. Now, what is our slope? It's right here in front of our x term. Negative 5/3 is our slope. Now looking at number 22, we're finding the slope that passes through these two ordered pairs, these 2 points, negative 4, 5, negative 8, 3. Now first what we did was labeled our x and y coordinates for the points. For the first point we labeled x sub 1, y sub 1, and the second point x sub 2, y sub 2. To get the slope when you have 2 points is you take the difference in the y terms divided by the difference in the x terms. That's what this delta means. Delta y means we subtract the y coordinates. Delta x, we subtract the x coordinates. Now remember, whatever order you subtract your y coordinates, make sure that it's the same order that you subtract your x coordinates. So if you do the first minus the second or the second minus the first, make sure you do the same order both times. What we did, we took our delta y, so looking at our y coordinates, we have a 5 and a 3. We took y sub 2 minus y sub 1. So the second minus the first. 3 minus 5 gives us negative 2 in the numerator. And then in the denominator, the difference in y's, we're going to use that same order. X sub 2, negative 8, minus x sub 1, minus negative 4. Remember, these two negatives become plus. So in the denominator, negative 8 plus 4 gives us negative 4. And negative 2 divided by negative 4 is positive 1/2. This is our slope. Now for problem 23, what are the factors of negative 2x squared minus 13x plus 20? So to factor negative 2x squared, we factor using 2x and 1x. And then to factor 20, we use negative 5 and negative 4. The reason we're using both negatives, remember a negative times a negative, gives us positive 20. However, when we add these two numbers, we're going to get a negative value. Our middle term is negative. So we can check this work to make sure that we factored correctly. And the way you check the work is you multiply the inner terms and the outer terms and then add them together. So this is how you check to make sure that you factor correctly. The inner terms are negative 5 times x, that's negative 5x. And then we're going to add that to the outer terms. The outer terms are 2x times minus 4. That gives us negative 8x. When we add negative 5x plus negative 8x, we're checking to see if we get the middle term, which we do. If you see that you have negative 13x in this case, then you know you factored correctly. So this will be our answer. Now for 24, we're solving a compound inequality. I wrote a reminder here so that you'll know when you use parentheses, brackets, or parentheses again. You use parentheses anytime your symbol is less than or greater than. Use the brackets if you have less than or equal to, or greater than or equal to. And then use the parentheses if you have infinity or negative infinity. So we're solving both of these inequalities, and then we're going to write the solutions using interval notation. So we have 3x minus 1 greater than 8. We will add 1 to both sides of this equation. The ones cancel on the left side, leaving 3x greater than, carry down the greater than symbol. And then 8 plus 1 gives us 9. Then we want to divide both sides of the inequality by 3. So x is greater than 3. Or in the second inequality, x plus 7 less than negative 7, x plus 7 less than negative 3, we want to subtract 7 from both sides of the equation. The 7s will cancel on the left side, leaving x less than negative 3 minus 7 gives us negative 10. So these are our two solutions, x less than negative 10 or x greater than 3. We write terms that are greater than 3 using 3 as our limit, and because our inequality symbol is greater than, we're going to use parentheses at 3. So numbers that are greater than 3. So if we look at this on the number line, numbers that are greater than 3 are going to be out here to the right. That's the direction of positive infinity. So we have positive infinity with parentheses and 3 with parentheses. Or, this U is our symbol for or. Now our negative values, because they're smaller, are x less than negative 10. If we're on our number line and we have negative 10, numbers that are less than negative 10, look at that arrow, we would shade to the left of negative 10. That's in the direction of negative infinity. We have negative infinity with parentheses around it, comma, negative 10, parentheses as well, because our symbol is less than. So this will be our answer in interval notation. All right, let's look at number 25. We're going to solve this equation. We see we have 2 times x plus 5 minus 13 equals 2x minus 3. So we need to distribute this 2 on the left side. 2 times x gives us 2x. 2 times 5 gives us plus 10. Then we'll carry down our minus 13, the equal sign, and our terms to the right of the equal sign. Now we see 2 terms on the left that can be combined. 10 minus 13 gives us negative 3. Carry down your 2x, your equal sign, and 2x minus 3 on the right side of the equal sign. We see that 2x minus 3 does equal 2x minus 3. We have both sides equivalent to each other. What does this mean? That our solution will be all real numbers. Any number that you substitute for the value of x will make both sides of these equations equivalent. So our solution will be all real numbers. Or using interval notation, we can write it as the numbers from negative infinity to positive infinity. For 26, we're solving for x using the square root property. Now we have 4x squared equals 24. Our goal is to get this x squared term by itself. That's how we want to apply the square root property. We need to get x by itself. To do that, we have to divide both sides of this equation by 4. The 4's will cancel on the left side, leaving x squared. And on the right side, 24 divided by 4 gives us 6. So now the value of x is plus or minus the square root of 6. This will be our solution. Okay, so values square root 6 or negative square root 6. And that's what plus or minus square root 6 means. These two mean the same thing. All right, let's look at number 27. We're solving for x. We have ax equals c minus dx. Now for solving for x in this case, you see we have two terms that have x in them. We need to bring those two terms together. So we add dx to both sides of the equation. When we add dx to the left side, we get ax plus dx. When we add dx on the right side, they cancel, leaving c. Now we want to factor out this GCF, this factor of x. So we factor x from ax, that leaves a in parentheses. When we factor x from dx, that leaves d in parentheses. We have a plus d times the x equals c on the right side of the equal sign. Now remember, we're trying to get x by itself, and we're multiplying by a plus d. So we're going to divide both sides of the equation by a plus d. That cancels the a plus d on the left, leaving x. And on the right side, we have d divided by a plus d. So this is our answer. Now for 28, we have negative 36 raised to the power of 1/2. Now you can simply plug this into your calculator as you see it. Also, you can remember that raising a base to a fractional power, we can write that in root form, where that bottom number of the fraction becomes our root. So this is the square root. This is like being the 2. And then the numerator is the power. So this is the same as negative 36 to the first power. And we know that we don't have square roots that wind up being negative. There's no such thing as a negative square root. Because every time you square numbers, negative or positive, you wind up with a positive digit. Therefore, we need to recall the imaginary number. Remember, the square root of negative 1 equals I. So we take out the negative from negative 36. We separate negative 36 using the factor square root 36 times square root negative 1. So we factor out the negative. That leaves us with positive square root 36. And the square root of 36 is 6. And the square root of negative 1 is I. So our answer is 6i. So you want to remember this fact that the square root of negative 1 equals I. Let's look at number 29. We're solving this equation, 5x squared minus 30x equals 0. We notice here on the left side that 5 and 30 can both be divided by 5. Also, x squared and x, we can divide out of x. So our greatest common factor is 5x. We factor 5x from both of those terms. When we factor 5x from 5x squared, we get x in parentheses. And when we factor 5x from negative 30x, we get minus 6. Now we have these two factors. We want to set them each equal to 0. So 5x equals 0 or x minus 6 equals 0. And we solve both equations. So 5x equals 0. We want to divide both sides of the equation by 5. That gives us x equals 0. One of our solutions is 0. Or on the right side, we want to add 6 to both sides of the equation. And we get x equals 6. So 0 or 6. Number 30, draw a linear system which has one point of intersection. And that just means draw two intersecting lines like you see here. And that one solution is going to be that point where those two lines intersect. All right, let's look at number 31. We have x equals x plus 12 raised to the power of 1/2. Now, just like before, we can change this fractional power to root form. Our denominator becomes our root, so it's square root, and then we have x plus 12 raised to the first power. Now we have x equals the square root of x plus 12. In order for us to get x, we're going to do the opposite of taking the square root. And the opposite of taking the square root is to square the number. So we want to raise that square root of x plus 12 to the second power. Now whatever we do on the left, we must also do on the right. So we also have to raise this x to the second power. Now x to the second power on the left side gives us x squared equals. Now squaring a square root just removes that square root symbol. So we're left with just x plus 12 without the root. Now to solve this equation, we want to get all of our terms on the same side of the equal sign. So we subtract x and we subtract 12 from both sides of the equation. That leaves us with x squared minus x minus 12 equals 0. This trinomial over here on the left we can factor. So we factor our x squared using x, and we factor negative 12 using negative 4 and positive 3. Now we want to set both of these factors equal to 0. So we have x minus 4 equals 0, or x plus 3 equals 0. And to solve this x plus 3 equals 0, we had to subtract 3 from both sides of the equation. That gives us x equals negative 3. But remember, we can't have a negative underneath our square root symbol. There's no such thing as the square root of 9 giving us negative 3. These two are not equivalent. If we substitute that value, so that negative solution will not work. However, when we solve the x minus 4 equals 0, we add 4 to both sides of the equation. That gives us x equals 4. If we check this answer by substituting 4, just like we did with the negative 3, 4 plus 12, that gives us the square root of 16. Does that equal 4 squared? 16. Does that equal 4 squared? 4 being that term on the left side. And that's true. The square root of 16 is 4. So our solution that works is x equals 4. For number 32, the hypotenuse of a right triangle has a length of 5. Remember, the hypotenuse is the side that's across from the 90-degree angle. One of the legs is 3, so it doesn't matter which side you write is 3. Find the length of the remaining leg. So the one we don't know, we put x as that leg. Now what we know about the sides of right triangles is that we could use Pythagorean theorem to find missing lengths. Remember, Pythagorean theorem is a squared plus b squared equals c squared. C being the hypotenuse. In this case, our hypotenuse was 5, so we substituted 5 for c. That gives us 5 squared. And then our legs, x and 3, x squared and 3 squared. Gives us 9, and 5 squared gives us 25. So we want to solve this equation. We subtract 9 from both sides. We'll get x squared equals 16. So using our square root property, we know that x equals plus or minus square root of 16. But the square root of 16 is 4. So plus or minus 4 are possible solutions, but we want to check them. Now when we check positive 4, we see that that works out. We plug in 4 for our x value. We see that we get a positive 4. However, negative 4 would not work because there's no such thing as having a negative length, right? So negative 4 would not work. Our solution is positive 4 only. All right, number 33, the sum of two numbers is 19. Remember what that word sum means, to add two numbers together. And because we don't know what those two numbers are, we're going to use X and Y. And then you're told that the difference of those same two numbers is 5. So we got two equations here. X plus Y, the sum equals 19. X minus Y, the difference equals 5. Now to solve this system, we just add the top and bottom equations. 1x plus 1x gives us 2x. The y's cancel. And 19 plus 5 gives us 24. We then divide both sides of the equation by 2. We'll get x equals 12. So 12 is one of the numbers, right? We have to then go back and find the second one. So if our x is 12, we have to go back and plug in that value of x into either of these equations so we can get y. So we substitute into the first equation, which remember was x plus y equals 19. But now that we know x is 12, we substitute 12 for x. We solve this equation by subtracting 12 from both sides, and we'll get y equals 7. So the two numbers are 12 and 7. For 34, we have f of x equals 0.275x minus 546.2. This is the function, and it represents the number of cars in millions that were sold between 1991 and 1999. We got to find the number of cars that were sold in 1993. So if x represents the year, and this is our function, where x equals, well, this function gives you the value of cars in millions that were sold between 1991 and 1999. So we're going to substitute 1993 for the year. So everywhere we see x, we're going to plug in 1993. So f of 1993 gives us 0.275 times 1993 minus 546.2. Plug this into your calculator and you'll get 1.875. And remember that number, that decimal represents millions. So it's 1.875 million cars in 1993. All right, number 35, we have 3 over x minus 2 equals 5 over x plus 1. We want to cross multiply when we see these two fractions with an equal sign between them. And we want to set both of those products equal to 0. So 3 times the x plus 1 equals 5 times the x minus 2. We then have to distribute on both sides of the equation. So 3 times x, 3x, plus 3 times 1 gives us 3. 5 times x gives us 5x. 5 times minus 2 gives us negative 10. We want to combine like terms. So we subtract 3 from both sides of the equation, and we subtract 5x from both sides. When we do that, we'll get 3x minus 5x gives us negative 2x equals negative 10 minus 3 gives us negative 13. We divide both sides by negative 2. So x equals negative 13 divided by negative 2. But remember, negative divided by negative gives us positive 13 halves. And that's our answer. For 36, we got to use the quadratic formula. And remember, this is our quadratic formula. X equals negative b plus or minus b squared, the square root of b squared, minus 4ac, all divided by 2a. Now here's our equation. We have x squared minus 2x plus 8 equals 0. Remember, x being by itself gives you an a value of 1. So our a, b, and c is what you want to find out first. Our a, the term that's in front of x, is 1. Our b, the term that's in front of or x squared for the first one. The b is the term that's in front of x, and that's negative 2. C is the constant, 8. That's the number without the variable. Now it's just a matter of plugging these numbers into the formula. So we'll get minus negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 8. square root of all these terms divided by 2 times 1. So under our square root, we get negative 28, and that's 2 plus or minus the square root of negative 28 divided by 2. Now this square root of 28, we can simplify that by finding the factors. Remember, we want to factor out that negative 1 first, right? And 28 can be written as two numbers that multiply together to give us 28. 1 being a perfect square is 4 times 7. Now we know the square root of 4. The square root of 4 is 2. We also know the square root of negative 1. It's I. And what's left is the square root of 7. So we have 2 plus or minus 2i times the square root of 7 divided by 2. All of these 2's can cancel each other out, leaving 1 plus or minus I square root 7. And that's our answer. For number 37, we have find the volume of the cube whose sides have lengths 2xyz, and the volume formula is the side length cube. So when we substitute this length, 2xyz, we substitute that for our length into the formula. So it's just 2xyz to the third power. And that just means raise all of these numbers to the third power. So 2 to the third power gives us 8, x cubed, y cubed, z cubed. That's all we have, our volume. Now we have the length is equal to the width to the power of 1/3. If the bird weighs 8 pounds, find the length of the wingspan. So we're going to substitute the weight W, we're going to substitute the number 8. So that's 8 raised to the power of 1/3. And we can write this 1/3 in root form. The denominator becomes our root. So we're really taking the cubed root of 8. You can just plug that into your calculator and you'll get the wingspan of 2. All right, now the last two problems, 39, we have this formula. Suppose this function gives you the position of the height when an object is above ground based on the time t in seconds. Now, when will the object hit the ground? So that's when our height is going to be at a point of 0. So when is that t value equal to 0? We want to first substitute our height for 0. And then we need to get all of our terms, right? We want to solve for t squared, so we can factor here. We have negative 16t squared on the left, or on the right side, plus the 32t. We could factor out negative 16. All of these terms can be divided by negative 16. That's our GCF. Well, both of these terms on the left side, excuse me. So if we factor negative 16 from negative 16t squared, we get t squared. We factor negative 16 or divide negative 16 from 32, we get 2t. That's us factoring out that negative 16. Now, once we do that, we'll get t squared minus 2t equals 0. Factor the t from both of these terms. Factor t from t squared, we'll get t. Factor t from negative 2t, we'll get minus 2. And then we set both of these terms equal to 0. So t equals 0 or t minus 2 equals 0. T minus 2, we want to add 2 to both sides of the equation. And we'll see that the time can't be 0, right? So our other solution, t equals 2, is going to be the correct answer. For number 40, you have two fractions, x squared minus 3x divided by x squared plus 2x minus 15. And we're dividing by another fraction. Remember, when you divide by a fraction, that's the same thing as multiplying by its reciprocal. So we want to keep, change, flip. This first fraction stays the same. We change our operation from division to multiplication, and then we flip the second fraction. So the terms in the numerator move to the denominator. That terms in the denominator moves to the numerator. We have 2x plus 10 over 7x. Now this x squared minus 3x, we can factor x from both of those terms. X from x squared leaves x. X from minus 3x leaves minus 3. On the right side, we can factor 2 in the numerator. 2 from 2x leaves x. And 2 from 10 leaves 5, leaving x plus 5 here. In the denominator, we have x squared plus 2x minus 15, which we factor using x plus 5 and x plus 3. The 7x stays in the denominator on the right. Now we want to cancel the terms that are alike. All right, and that leaves x times, well, 1x cancels. So that leaves 2 in the numerator, 7 in the denominator. This is our answer.